Okay, so for number 3, we're going to begin by labeling our equations first. So I'm going to call this first equation equation 1. And I'll call my second equation equation 2. Now what I want to do is add equation 1 to equation 2 so that I can either cancel out my variables for C or my variables for D. In this case though, I first want to get them into the form ax plus by equals to C. And because the variables are C and D, for this case, I want them in the form AC plus BD equals to capital C. So let's do that. It looks like equation 1 is already in that form, so I just have to change equation 2 to that form. So for equation 2, I have 7C equals to 3D plus 2. So in order to move my D term over to the left-hand side, I would subtract 3D from both sides. And once I've done that, I should get 7C minus 3D equals to 2. Okay, so now let's rewrite our equation 1 and 2 together next to each other and see if we can pretty much add and subtract them together to cancel out one of our variables. So if I write them together, I would have 2C plus 5D equals to 17, and 7C minus 3D equals to 2. Okay, notice that I want to add these equations together to cancel them out. But if I add them together, positive 5D plus negative 3D would get me positive 2D. And what I really want is 0. So I have to either turn the negative 3D in my second equation into negative 5, or I change my positive 5 in equation 1 into positive 3. But doing so requires multiplying every term by a fraction. So instead of working with fractions, what we can instead do is multiply both the first equation and the second equation by a whole number that can still make this possible. So here's my plan. I think I'm going to, for equation 1, multiply every number by 3. So I'll multiply every term by 3. And for equation 2, I will multiply every term by 5. And if this seems familiar, it should be, because what I'm basically doing is when I multiplied 5 by 3 and 3 by 5, I'm just multiplying them to find the lowest common factor or difference. No, lowest common factor, and that'd be 15. So for the first one, 2C times 3 should be 6C, plus 5D times 3, which should be 15D. And that equals to 17 times 3, which should be 51. Now for my second equation, I have 7C times 5, which should be 35C, negative 3D times 5, which should be negative 15D, and that equals to 2 times 5, which should be 10. Now notice in this format for these two equations, if I do add them together, because I have positive 15D and negative 15D, I would be able to cancel out my terms for D. So what I would be left with is 6C plus 35C, which would give me 41C, and that would be equal to 51 plus 10, which would give me 61. Now from here, I want to have C by itself. So what I'm going to do is I'm going to divide every term by 41. And if I do that, I should get C by itself, because 41 divided by 41 is 1. So C equals to 61 over 41. Now from here, I would try to reduce 61 divided by 41. But as you can see, 61 over 41 cannot be reduced. So my final answer would be C equals to 61 over 41. Now what I want to do is I want to take my value for C and plug it back into equation 1, or equation 2. So I think the easiest way to do this is to plug it back into the original equation 1. So that's what I'm going to do. So my original equation 1 is 2c plus 5d equals to 17. So I'm going to plug back in the value of c. In this case, the value of c is 61 over 41. So instead of 2c, I write it as 2 times 61 over 41 plus 5d equals to 17. Now, this is the tricky part. So I'm taking 2 and I'm multiplying it to 61 over 41. But recall this, 2 is essentially 2 over 1. So what I really have is 2 over 1 times 61 over 41. And that's plus 5d equals to 17. But remember what happens when we multiply fractions together. I multiply the numerator by the numerator and the denominator by the denominator. So what I essentially have is 2 times 61 divided by 1, I guess I'll erase that, 1 times 41. And that's plus 5d equals to 17. So let's move that whole equation over here now. So 2 times 61 is just going to be 122. And 1 times 41 should be just 41. So I have 122 divided by 41 plus 5d equals to 17. From here, what I want to do is I want to subtract 122 divided by 41 from the left-hand side to the right-hand side. So I would subtract 122 divided by 41 and subtract 122 divided by 41 to the right-hand side. Because what I do to one side, I have to do to the other. And what I would have left is 5d equals to 17 minus 122 divided by 41. Now, here's an even trickier part. Remember the rules for adding or subtracting fractions. In order to do so, I must have a common denominator. So what I'm going to do is I'm going to make 17 common to 122. So what I think I would do is I would probably multiply 17 by 41, top and bottom. So 17 over 1 times 41. So if I do that, what I get is 5d equals to, 17 times 41 should be 697. And 1 on the bottom, because it's 17 over 1, times 41 should be 41. So now I have 697 divided by 41 minus 122 divided by 41. And for the rules of subtracting fractions, I would just subtract the terms in my numerator and keep my terms in the denominator the same. So what that means is 697 minus 122 over 41, because I keep my denominator the same. And what I get from that is 5d equals to, 697 minus 122 should be 575. So I got 575 over 41. So now I want to divide 5 from both sides. So I would divide 5d by 5 and 575 over 41 by 5. And if I do so, on my left-hand side, I should just get d, right? Because 5 divided by 5 is 1, so that would just be d. But on my right-hand side, I have essentially 575 divided by 41 divided by 5. And I'm just going to say this is 5 over 1 because I can write 5 as 5 over 1, right? But remember for the rules for division. The rules for division state that when I'm dividing two fractions, what I do is I keep my first term the same, and my second term I take the reciprocal, so meaning I flip the numerator and the denominator, and I multiply instead. So this would be 1 over 5. So now I just multiply by 1 over 5, pretty much. So 575 divided by 41 times 1 over 5. And when I do that, I would be getting 575 times 1 divided by 41 times 5. And 575 times 1 should just get me 575. And 41 times 5 should get me 205. And now I want to reduce this down as well. So this can be reduced down. So if I divide the top and the bottom by 5, I can reduce this fraction down to 115 divided by 41. And that would be my answer for D. So that means if I scroll back up now, my answer for C was 61 over 41. So I would say my final answer is C equals to 61 over 41 and D equals to 115 over 41.